Hello, viewers. Welcome again to the episode 11 on static mechanics. Still picking question to text the things that we've done in episode 2 and 3. So, a body of mass which is 8 kg is on a point of sliding or slipping down a rough plane of inclination 30 degrees to the horizontal. So, what is the magnitude of the force P, which when applied along the plane will just move it up? So let's see if we can make a sketch of that diagram. I'll try and see if we can manage this space and make the sketch of that inclination. So if the body is here, the center of gravity is here. So the weight will be coming down with W being equals to mg. The angle of inclination is 30 degree. Then the normal reaction at perpendicular to the surface. So this is going to be R. Then the normal reaction have downward movement also, which is also labeled as mg cos theta. Now, when a force is applied along to move this body up, that force is P. And that force, when applied, will be resisted or will face with resistance. That resistance force is what we call the friction. Then there is also a force keeping the body from sliding down or along, which make it to be at rest. The force that keep it at rest, which is also labeled mg sine what? Theta. This place is also angle theta, and this is the surface on which the body is placed. Alright, so if this is drawn well, the question we are asked is what is the magnitude of the force P, which will be applied to move the body up. Now, when this is moving up, remember the force mg sine theta is going in the opposite direction as the friction. Since there is no, this is not a smooth surface, so there will be friction available. So what will I do? If I pick forces that are along the surface, let me just call it parallel forces. The parallel forces is going to be the force going up, which is P should be equal to the sum of forces going down. And the forces going down is going to be F plus what? The mg sine theta. That is what is going to happen in here. So I am looking for that force, and I know the mass of the body, the gravity is known, sine of the angle of inclination 30. The only information that I'm not giving is what? The friction. But don't forget the friction or frictional force, which is the limiting force, also have a formula. We know if this is under inclination, we have our frictional force, which is proportional to the normal reaction, and the constant of proportionality is the coefficient of limiting friction, this one. So this can be calculated. This is can also be calculated. So if I know that the angle of inclination is given as 30, that means that your coefficient, which is the mu, equals to the tan of the angle, which in this case is what? 30. So I can find the mu easily. Find tan 30. So I leave it in decimal or leave it in. Okay, let's see. So tan 30, let's leave it for a set form first and see whether we can reduce that in the calculation. Then our normal reaction, I think we need to resolve that before. So let me see. This is going to be equation 1. Then for let's say vertical forces, or forces parallel to the plane. Let's call it forces parallel, perpendicular to the plane. So those forces are going to be upward force and downward force. And the upward force is the normal reaction equals to mg cos what? Theta. And by substitution, let me buy space here. Okay, let's bring it down. 8 as the mass times gravity times the cos of the angle what? 30. So if I have 80 times cos 30, that is giving me the value of 40 root what? 3, the normal reaction. That's the force in Newton. Alright, so I think I've answered that question we asked to find it. What is the magnitude when applied? No, we are not looking for the normal reaction, but we can indicate the unit if you want to. So we can say that from equation 1, the force we are looking for is equals to this F, which is going to be this times the normal reaction. So the root of 3 over 3 times normal reaction 40 root 3. Then where are we going? This is plus. So plus m, which is also 8 times 10 sine what? 30. Alright. This is 1 over 3. So we can multiply the root by the root. And the root by the root will give you root 9, which is 3. And 3 times 40 divided by 3 will be 40. So we are having 40 here. Then let's add that aspect to it. So we have 40 plus. So 80 sine 30 will also give you 40. So when you put that together, you should be having 80 what? Newton. So the value of force that, or the magnitude of the force P, which when applied along the plane will just move the body up. When it moves the body up, it means the forces, the frictional force is less than that of the what? The force that applied. That is why it can move. Alright, I guess this is also clear. If you check episode 3 carefully, we can see that we have various aspects of the equilibrium that we have. For a body on the flat surface, we have about 2 cases which we are picking question on. For that of the inclined plane, we have 3 cases, and this is one of the, I think the second case. We will try and find a question that will text the third case also. So keep glued to the channel as we keep the series in motion. Like, share, comment, and subscribe.